もしもーし。
Welcome back to my channel. Today we're going to pick up where the last video sorta left off and cover a thing called conditionals. It's like a condition in a relationship, except less toxic. If some condition is true, then something happens. Otherwise, maybe something else happens. Maybe not. Cause and effect. It's also the primary use of the booleans we talked about in the last video. First though, we need to bolster our boolean toolkit a little bit more, and this one's going to include a little bit of math. Do you remember inequalities? 3 less than 4, 6 greater than 5, etc. Well, they're also true and false statements too, aren't they? Because of that, they're also useful in our conditionals. So you can do things like, if a numeric variable is greater than some arbitrary number, then do something. As a reminder, our inequalities are less than, greater than, equals to, not equals to, greater than or equals to, and less than or equals to. And we'll pretty much be able to make all kinds of complex checks using those. Also, since characters have associated numbers, they can also be compared in this way. And the concept of equals and not equals makes sense for strings, but they aren't handled the exact same way, so for now we'll just put a pin in it. In programming, we're pretty straightforward in our verbiage for these conditionals. We simply say if some condition for our conditional check, then we use those squiggly brackets to surround whatever we want done if the condition was true. So let's make a boolean called is this a JoJo reference, and set it to true. Then we'll write a conditional if check below it to print if it's true. So if is this a JoJo reference, system.out.println, yes, everything's a JoJo reference. Okay, but what if, by some satanic miracle, it wasn't a JoJo reference? Well, let's set is this a JoJo reference to false, add a new conditional below our current one using our not to signify if not a JoJo reference, then print this other thing. If not is this a JoJo reference, system.out.println, NANI? Everything is a JoJo reference. But it'd be really cumbersome to write everything as if this, if not this, for every single time we have a split path where we do two different things based on a true-false result. So programming gives us a streamlined way of doing this called else, which just means if our previous check didn't pass, then no matter what, do this. And we can combine our two lines to just, if is this a JoJo reference, else. Now, when we toggle our reference between true and false and run it against this, we can see it keeps jumping back and forth between the two options. But what if we have multiple things we might want to be true or false? This is also supported. So let's do some setup first and add a new boolean, is this a Star Wars reference, and set it to false. And we want to add an if statement for is this a Star Wars reference boolean. Now, for this example, we're going to create a little flow we want to check. First, we'll try to see, is it a JoJo reference? If so, then that'll be our number one priority. If it isn't a JoJo reference, well, maybe it's a Star Wars reference. Our if else would automatically print NANI? But we don't want to do that unless our reference is neither from Star Wars or JoJo. So what we can do is create a little extra space between our if and our else and add a hybrid of the two, else if. So we add else if, is this a Star Wars reference? And then we can add another print statement for this is the way. Now you can see our flow is if this is a JoJo reference, print this. Otherwise, if it is a Star Wars reference, print this other thing. And if all else fails, print this last thing. And you can do this for as many means and checks as you want. If is this a JoJo reference? Else if is this a Star Wars reference? Else if is this the meaning of life? Etc. And then cap it with an else or nothing at all. If you only want to print if we know 100% that something is a reference, we can just leave it there. You don't have to do an else unless there's something you want to print no matter what, and that will always be the last in the segment anyways. The only mandatory part of this topic is the if check, because it allows you to do something only if the universe deems you worthy. Kind of like Thor's hammer. Now, so far we have been focused on simple true-false checks. But remember those ands and ors from the last video? Well, what these if checks really care about is whether the entire thing in the parentheses is true or false. And you can take a whole bunch of these comparisons all at once and then add them together using those ands and ors. This is why I taught you that quick inequalities refresher at the start of the video. So let's make an integer number equal to 8, and we're going to do a compound check for this next if statement. If number is less than 10 and number modulus 2 equals 0, then we can print out, a small even number. When we run this, the print line works. And that's because 8 is less than 10. And using our crazy modulus math, we see that 8 divided by 2 doesn't have a remainder. And actually, this modulus 2 equals 0 check is our number even check. And you should probably try to remember that. So the print statement is right. 8 is a small even number. Now, if we're to set the number to 7, the print no longer appears because 7 is odd. And if we try with a 12, it also doesn't print because 12 is bigger than 10 even though it's even. That's because we did an AND check. Try different numbers and checks and try switching out the AND for an OR and just experiment. It's the best way to learn. I'm going to stop the video here, but in a later video we will discuss something called switch statements, which are a very special way of writing our if, else block, but are a little too complicated for where we are now. But you might see them if you do your own research, so I just want to get them out there into the ether. Until next time,
bye, have a great time!
Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.